Welcome to lesson 6.3, use similar polygons. So again, what you want to remember is the term polygon just means a closed figure made up of line segments, and it has 3 or more sides. So similar. We already explored the idea of congruence. Now we're getting into the other common one, which is similarity or similar figures. So similar can be defined as two polygons are similar if their corresponding angles are congruent and their corresponding side lengths are proportional. And we have been looking at proportions, meaning equal ratios. So you would simplify the fraction to see if they have the same fraction or ratio between them. And we'll explore that idea as we go through the notes. So to be similar, corresponding angles are congruent, same measure. Corresponding side lengths are proportional. So for example here, if we're looking at these two figures down here in the diagram below, ABCD is similar to EFGH. We write that as ABCD, and this single squiggly here is a symbol for similar. So polygon ABCD is similar to polygon EFGH. Our corresponding angles are the ones that have the same measure and are in similar spots, meaning bottom left to this figure is A, here is E. B corresponds with F, C corresponds with G, and D with H. The other way you can identify correspondence is the way that we write it in the similarity statement. If A is the first letter on this shape, it corresponds with the first letter on this one, which is E. B here corresponds with F, C corresponds with G, and D corresponds with H. So now, that takes care of the congruence part. Those all need to be congruent for corresponding angles. The ratios of corresponding sides all have to be proportional or equal. So A over B, not A over B, side AB over side EF should simplify to the same ratio as BC over its corresponding side FG. And CD should simplify over GH to the same number, and AD should be over EH or HE, and all simplify to the same number. So it kind of goes back to that idea of a scale drawing, and it keeps the same scale. So now if we look at example 1, list all pairs of congruent angles. So in this case, they tell us triangle RST is similar to triangle XYZ. So for part A, angle T up on top would be congruent to angle Z. Angle R is congruent to angle X, and angle S is congruent to angle Y. Then in B, it says check that the ratios of corresponding side lengths are equal. So what we want to do is you want to select one side off of one of the shapes. So in this case, I'll use XY. And that I'm going to put over its corresponding side of RS. So XY over RS is 12 over 20, which simplifies to 3 over 5. Then, because I started with the smaller shape on top, I need to keep that for my other relationships. So in this case, we'll use YZ, which is 18. That corresponds with TS, which is 30. So YZ over TS, 18 over 30, also simplifies to 3/5. And then we have our final side, ZX of 15 over TR of 25. 15 over 25 also simplifies to 3/5. So these ratios all need to be the same in order for it to be proportional and similar. And then it says in C, write the ratios of corresponding side lengths in a statement of proportionality. So that's taking each of these individual pieces that we checked and setting them equal to each other. So xy over rs equals yz over st, which equals zx over tr. And that is your statement of proportionality. So that idea of similar goes with the idea of a scale factor. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. So our scale factor up here would be 3 to 5. 3 over 5. So in example 2, determine whether the polygons are similar. If they are similar, write a similarity statement and find the scale factor. So in here, our first thing to check is if these are similar. So I want to start, and it doesn't matter which shape we put on top. I'm going to use the shape on the left for the top, shape on the right for the bottom. So I want to start with corresponding sides. 16 corresponds with 20. So 16 over 20 simplifies to 4/5. Then 12 corresponds to 15. 12 over 15 equals 4/5. 24 corresponds with 30, simplifies to 4/5. And 20 corresponds with 25, simplifies to 4/5. So if all the sides simplify to the same ratio, they marked that all of our angles are congruent already. Are these shapes similar? Yes, they are. Now our similarity statement would be taking what we already did over here and just writing it out. So this would be, for example, we could start with Fj over, and Fj here was over Zw over Zw. And then that would equal, then you can pick the next side that you did off the left shape. So Jh over, so we have Jh over Wx. And then you would set that equal to the next two that we did over here. So it'd be GH over XY, and then that would be equal to GF over YZ. So looking at example 3 here, it says in the diagram, triangle DEF is congruent to MNP. Find the value of X. And this is why we did the refresher on proportions. Similar shapes are proportional. So if we know it's similar, we can set up a proportion. X goes with 20. So I set it up as X over 20, and the 9 corresponds with 12 equals 9 over 12. Then to figure out the value of X, we're just going to cross multiply, then divide. So 20 times 9 is 180. So 12x equals 180, divide by 12, and x is 15. Now we get down to example 4. It says, in the diagram, quadrilateral ABCD is similar to quadrilateral QRST. What is the scale factor of QRST to ABCD? So in this case, our scale factor, QRST to ABCD, because they listed QRST first to ABCD, QRST needs to go on top. So to figure out our scale factor, they already told us they were similar. So we could take any set of corresponding sides. So I could use the 5 here, QT, over the 10 here. I could do the 8 over 16. I could do the 6 over 12. Any of those 3 sides, all of those give me the scale factor when simplified of 1/2. So our scale factor is 1/2 or 1 to 2. Then we're going to use this idea to find the value of x. So we're going back to what we did here, the idea of a proportion. So we know the x corresponds with 4. So if I do x over 4, I started with the shape on the left on top, so I need to do the same on the other side. So if I use the 12, it'd be 12 over 6. So x over 4 equals 12 over 6. Cross multiply, 6x equals 48. Divide by the 6, and x equals 8. So all of that builds into our theorem 6.1, which is the perimeters of similar polygons. And it states if two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Meaning if KL and PQ had a ratio of 2/3, then the perimeter of this whole shape compared to the perimeter of this whole shape would also simplify to 2/3. So each individual corresponding side ratio ends up being the same ratio as the overall perimeters. So now we get down to examples 5 and 6. Example 5 is about a swimming pool. It says the town is building a new Olympic swimming pool. The pool is rectangular with a length of 50 meters and a width of 25 meters. The new pool is similar in shape, meaning same angles, but only 40 meters long. So first, find the scale factor of the new pool to the Olympic pool. So new pool to the Olympic pool means new pool on top. So new pool was 40 meters. Olympic pool was 50. 40 over 50 simplifies to 4/5. So our scale factor is 4/5. Now we're going to use that scale factor to find the perimeter of the new pool. So the perimeter of our current Olympic pool would be 50 and 50, 25 and 25. So add that all up, 150. So the perimeter of the new pool over the perimeter of the Olympic pool equals our scale factor of 4/5. We're using this idea from the theorem. So then x over 150 equals 4/5. Cross multiply and divide. So 600 equals 5x, divide by 5, and x equals 120. So the perimeter of the new pool would be 120 meters. Now in example 6, tells us that our two pentagons are similar. ABCDE is similar to FGHJK. Find the scale factor of FGHJK to ABCDE. So on top would need to be FGHJK, bottom ABCDE. So our scale factor, which I believe I reversed here. I did. I didn't read my own directions. Our scale factor would not be 2/3, because that would be ABCD to FGHJK. So we would need to flip this. So our scale factor would actually be 15 over 10 or 3 over 2. Because again, the one before the word 2 should go on top. So you'll want to flip this one in your notes. Then it asks us to find the value of x. Well, in this case, if I took the x here, that corresponds with 18. So I'd have x over 18 equals, and then I'd use the 10 here, 15 here, 10 over 15. Cross multiply and divide, we get x to equal 12. Then we're going to use that information to help us come up with this perimeter piece. Well, knowing x is 12, we only have two sides on this one, so I can't figure out my whole perimeter. I have all the sides on this one. So when I add those up, I know that perimeter is 69. So I want to know the perimeter of this one, which we'll call x in this case, or y, whatever letter you want. So we would set that up as this perimeter, unknown, over 69 equals, and the scale of the smaller to the larger was 2/3. If you would put the 69 over x, then it would equal 3 over 2. So then in this case, then we need to cross multiply and divide. So 69 times 2 equals 3 times x. So 138 equals 3x. Divide by 3, and 46 equals x. So the perimeter of ABCDE is 46 units. And then our last kind of key concept to explore here is corresponding lengths in similar polygons. So if two polygons are similar, the ratio of any corresponding lengths in the polygons is equal to the scale factor of the similar polygons. So let's look at that idea. So example 7 here, it says in the diagram, triangle TPR is similar to XPZ. Find the length of the altitude PS. So we're looking for segment PS here. So what do we know? Well, we know this whole side on bottom for T to R is 12. We know this whole side on bottom of this triangle is X to Z, which is 16. So corresponding sides, 12 over 16. We're trying to figure out PS, which is X, and then over PY, which was 20. So 12 over 16 equals X over 20. Cross multiply and divide. So 240 equals 16x. X equals 15. So we know the length of PS is 15. Then in 8 tells us triangle JKL is similar to triangle EFG. Find the length of the median KM. So I'm looking for KM, which I'm going to make my variable, letter X. I know that corresponds with the 35 here. If I'd flip this triangle, then GE would correspond with JL. So JL is 96, GE is 80. So if I'm going to start with the smaller shape on top, it'd be 80 over 96 equals 35 over X. If you would have gone the other way, you could have gone 96 over 80 equals X over 35. End up with the same answer. Now we need to cross multiply and divide. So 96 times 35 equals 80x. So divide by the 80. And x is 42, meaning the median km is 42 units long. Ignore these practice problems down here. Those are not the correct ones. Please do the ones that are posted to Google Classroom with this assignment. But again, the big ideas come back to this idea of corresponding lengths being similar to the scale factor proportional. All of these proportional reasonings, and the idea that the perimeters keep the same ratio or scale as your scale factor of individual sides. But again, if you didn't do lessons 6.1 and 6.2, refreshing on ratios and solving proportions, you'll want to make sure you do those before working on today's lesson.